My name is Lilia Sosa, and today I'll be presenting number 41 of the all series test. The question goes as follows: determine whether the series is convergent or divergent. State which test you are using and verify that the conditions for using it are satisfied. So the series given is n to the n power times n factorial over quantity 2n factorial. But before solving this question, we must think about a test to determine if it is convergent or divergent. But we see that it has n factorial and we have an n to the n power. So the best test to use to solve this question is the ratio test. So let's review what is a ratio test. So the ratio test is primarily used to determine the convergence and divergence or divergence of infinite series, especially those involving factorials and exponentials. As we know, our question involves factorials in the numerator and the denominator. So it says, suppose we have the series a sub n, define the limit, which is limit as n approaches infinity of the absolute a sub n plus 1 over a sub n. So if we find the limit of that um, using this method, if the limit is less than 1, the series is absolutely convergent and hence convergent. If the limit is greater than 1, the series is divergent. And if the limit is equal to 1, the series may be divergent, conditionally convergent, or absolutely convergent. And now we're going to use the ratio test. So we're going to break it down piece by piece. For the n plus 1 factorial will be equals to n plus 1 multiplied by n factorial. And then the quantity 2n plus 1, quantity 2n plus 2 factorial will be equals to quantity 2n plus 2 times quantity 2n plus 1 times quantity 2n factorial. And then we're going to substitute them and then cancel the n factorial and the 2n factorial. Afterwards, we get that our limit will equals to um, quantity 2n plus 1 raised to the n plus 2 all over quantity 2n plus 2 quantity 2n plus 1 multiplied by n to the nth power. Now, using the asymptotic hierarchy, we get that our limit is equal to e over 4. So now that we have found our limit, we must determine if it is convergent or divergent by using and applying the ratio test rules. So then we know that our limit is e over 4 and that is less than 1. Therefore, the series has a limit that is less than 1 and it is absolutely convergent and hence convergent by the ratio test. So this is how we work out question number 41 of the all series test. Thank you.